So I think that's enough waiting. Everyone that wants to be here is here. I have a bottle full of tea to keep us through the night. A friendly bottle. We are going to get started. Regarding setup compared to last time, so now we have a browser in Emacs. I'm not super satisfied about how it works by default, and I didn't take the time to configure it. So sometimes we might get into states where I kind of panic about it. I haven't updated VTerm. It took me a long while to have the Emacs application framework EAF working for the browser. Therefore, I didn't want to jinx it by playing with VTerm again. Might do that for the next time. I don't know. For now, we are stuck with ANSI term, which just kind of works anyway. What was? Do we have a datalog file? Yeah. Okay. We can open datalog. We were somewhere at the bottom here. I can put another window in ANSI term. Oops. Yeah, bash will be fine. Right, so if I do build, should work. Nothing to do because it's all done. Here I want to turn on LSP. Fantastic. Okay, that seems to be working quite fine. There's a new version of Merlin that has been released and I have no idea. I haven't upgraded my Ocaml either. I will have to do that as soon as I want to use the new lead binders if I want to. There's a lot of code in this repo that could be simplified with this, but I never got around to it. It's been the same version 2 years on this repo, and it's mostly because Ocaml is a bit complicated to set up. Still, it's easier to do a global setup, so you never really know what happens when. For dev environments, I mean, like it's quite easy, but for dev environments tend not to be sandboxed properly. It's easy to not sandbox them anyway, and that's not the way. That's the way it's done here. I just have a global Ocaml environment. You never know what happens when you upgrade. I've been taken by other projects. At any rate, that's a lot of blabbering. So currently we have grouped of type relalg dot binding list. That's all very good. Okay, so the main thing that we did last time, let me just give me a bit of space here, was this function. So that's the goal. We don't really care about this actually. It's mostly this one that we care about. This one. So it takes a bunch of rules. So basically a program. I haven't put everything together, but it's all fine. We have a bunch of rules that we suppose are non-recursive, and we define relations. So each of these rules is just read as a definition, or you can have several definitions for the same thing, and then the new relation is the disjunction of all these rules. So you can do a let R equals blah or blah or blah, and you define that using the relational algebra thing that we've defined somewhere. It's here. There's a relalg. It's hard to say. Relational algebra module, and we see that basically we have a fairly standard thing. So it's point free. So this is just a relation. This is the top relation. These are intersection and union of relations. There's the cross product of relations. So we see relations as predicates from a set of tuples of atoms. So the cross product is just say any, like if I take all tuples from both and put all the possible connections. We can also filter on a certain property. I mean, I haven't written any semantics yet, but the idea is that we take two indices inside tuples of these relations. They're homogeneous, and so we just add the constraint that these two things are the same, and that's all we do. Each atom just says, oh, this index, it's the same thing, except there's just one column that we're looking at, and we're just filtering with equality to an atom. And proj says, oh, we're going to use a list of indices and just use these and just ignore the rest. So it corresponds essentially to existential quantification on the indices that are not listed. If I didn't mess up too much. Right, and we use and that's the rule. So usually explaining things is a bit shorter than programming it, but it's not terrible here. So I imagine I have a rule like this. So there's a bunch. That's what a rule looks like. I'm defining R of x, y to be this, or all the definitions. And I suppose it's non-recursive for now. We'll do recursion later. It's going to be important. So the idea is I read the rest as this particular cross product, so I add top. So why do I add top? It's because it gives me access to x and y. Yeah. Then whenever I see a y, I equalize it with the index, the second index here in top. So that's index 1 in general. And whenever I see an x, I equalize it with index 0. And whenever I see an a, I use eq atom for that particular index. And then I just actually ignore all this and just project on these two things. But I have filtered everything, so I got the right x's and y's. I'm not sure it's the most efficient definition, because anything involving top is going to be a bit problematic, but it's going to be fine for now. Yeah, basically. We're going to be using, I'm going to be missing the newfangled monad notation immediately. Wonder though. Oops. Ooh, there's a lot of things. I can't scroll. Fantastic. I don't care about build. Doing project, readme, datalog. I don't have an Ocaml file. If I read Dune here in source, there's the list of libraries. Shouldn't be too hard to move it to the new thing. I'm not going to do it today. I imagine if I mess up my Ocaml on stream, we had enough trouble last time. So let's say we don't do this. So my next thing I want to do, I guess, is going to have to occur somewhere in this module, and I want to say, oh, if I have an expression, a relational algebra expression, I want to turn it into some Boolean expression. Do I have I must have a Boolean expression thing. There was formula. That's quite definitely something. We'll have to generate variables. I don't know what type I want to give them, but yeah, that's a general idea. Where do I use formula? Interesting. Formula.t. I use it with A, which is a type of atom that I define somewhere. I don't know where I get it from. It's an abstraction. Okay, that's maybe not the most interesting use. Or maybe I okay, yeah, we use complex atoms everywhere. That is not a super great encapsulation, I guess. It was hard. So the provable by time is what we're really trying to remove. Yeah. But we'll just generate atoms, yeah. The general idea is we need to generate atoms for this, the instance. So each possible, in this case, they would be full of variables. Like each possible atom would tuple of atom which corresponds to variable, which can be big, I guess. We would want to add some bounds, some limits on what they can be, but we can do that later. So we're going to ignore this and just assume that we have how did we do? Did we assume? Because we just did rule, and did we assume we had a transformation for all of these? Right, we assume we had a semantics for all of them. We just replaced the thing by the same name. So in that, in the datalog to relational algebra, I didn't really care about where the definitions came from. Here we will have to. So we'll assume we have a. We'll assume that we have an environment. We're going to define. So we're going to define a type. And that would be for compiled expressions or compiled relations or relations. I'm going to just call it relation. Rel. I'm going to call it rel because it's and. Actually, I'm going to make a module. Are we going to make a module? Oh, there's a pain in the ass. Okay, lists. Fair enough. Map.make. So what do we want? We want T to be a list of something, of atoms. Do we have an atom type? Yeah, it's called atom. Yeah, right. Atom list. And for the time being, I'm just going to assume that like compare equals compare. In real life, we probably want to take atoms as an argument to this. More functors. Functors are very natural in this setting. Take them with their comparison function. It's actually all we need about atoms. We really only need that they're equal, but the fact that they can be compared is going to be tremendously useful. And we'll always want to do some translations between atom types. So yeah. I may want to clean this code at some point. It's not that much code. Like I have Really? Is that w.count or no? It's no count. Here we go. Oh, there was a w.count, but I was mistaken. 6,000 lines. What if I go to source? Because I think it's just everything is counted twice. Okay, 4 times actually. Yeah, so we have less than 2,000 lines. Okay. I did something. I don't know what it was. I did it again. Right. So yeah, we have less than 2,000 lines of code. Refactoring this will be a doozy when we get there. Plus, I hope that I can remove the timed logic entirely. I would simplify things a bit. But we have to be able to generate atoms for this. Not atoms. Well, yeah, atoms in the SAT sense, which are different from the atoms from the relational algebra thing. And right, there will be some sorry, I don't know, I'm not here today. There will be, as I was saying, some terminology issues, collisions, but we'll get there when we get there. They're sort of now, but I'm just going to call them var. I already have something called var over there, yeah? Right, it's a different kind of vars. So I'm going to call them sad vars. And there will be integers for now, I guess. These were no strings, but I think int is fine. To do a better name and abstract over abstract compilation over. We'll have to put some order into this. Right, so we're going to need this, and the idea is that like a relation type rel, oh dear, is sadvar, no, a sadvar formula.t of map.t. No, not map.t, rel.t. Okay. So we can kind of see them as matrices, and sometimes it's advantageous to parse matrices of sorts. So the idea is all the something happened. All the keys have the same length. Specifically, well, have length the arity of the relation, because they're tuples. And an absent key means false. Let's have formula open here. 0. I don't remember the syntax in Ocaml doc, so I'm not going to bother. Guess I should. An absent key means 0. Yeah, that's pretty much it. So you know, it's just it's just a finite Boolean predicate where some values may be unknown. Crucially, and will be offloaded to SAP, and we can see which. Then we can see which of these values work. So that's what the relation is. Some remark in the code paper, they don't use lists of atoms directly, but encode them as integers. I doubt that it is really useful in Ocaml. It's probably an artifact of their implementation language. Artifact. I'm not sure. That's my guess anyway. To do probably in the code paper again. They they represent sequences of contiguous 1. That's true. As a single interval thingy rather than a bunch of key value pairs. Since our encoding uses true, or the top relation, we can expect such an optimization to be quite dramatic. But I don't really know yet how to do this optimization while keeping the implementation complexity reasonable. And by reasonable, I mean that I can be bothered doing. So that's my feeling. I don't understand how they do this. So they're not very explicit on the implementation and how they actually represent their matrices. By the way, so if you write in code directly, or even in Alloy, which is really, I think, even it's the most popular, but it's also the earlier attempt by the same team to write relational algebra thing. They rely significantly on relation composition, and that's just that is just a relational, a matrix product, so it's associative, etc. Well, we know that. That being said, a product is really defined in this sort of matrices. Like if you have this key value representation of matrices, it's a cross product followed by a same on the first of one and the last of the indices in which you compose, and then a projection to kill one of them. Well, to kill the two of them, really. So it's really it's easier to define with the inverse projection, but I mean they're interdefinable. It doesn't matter if you can know the arity of everything, which I believe we do. That's the way I would define it anyway. I think I haven't found any better way. So it doesn't add much, except that they also, in Cod at least, they have the transitive closure of a relation. That's only for binary relations. And that can be that can use a faster exponentiation algorithm. That's pretty cool. We don't have anything that is of the sorts, I'm afraid. So, nope. Anywho, back on our topic, we just found a type in a comment right now, or 2 times. So we're going to have one of these. So we can define an environment, which is I need a module again. That's going to be a map. What was the type declaration again? Name and arity, yeah, okay. There's going to be a map, struct end. Now it should tell me that, oh, well, that's interesting. Signature, it says signature mismatch here, but it doesn't really tell me what's wrong. I don't know why that is. Even if I do a big one, yeah, it's just stuck there. It's kind of weird. I know what it is. That's fine. There's going to be a declaration. And compare is compare. Here, there's not really much to say about it. And an environment will just be rel map.make. No, not map.make, env.t. Fair enough. So now we have values for all the things, and we are just assuming for the time being that we have a bootstrap environment with all the variables. So I'm not going to introduce any new variable. And that whenever we read a relation, all the relations in it are already defined by a previous compilation or the bootstrap thing. I fear that I'm putting back everything that is boring, and I will have to do all the boring stuff in one stream, which is a bit worrying, but that's fine. So again, to do initialize the environment. It can't find a solution. Environment with values for all the instance relations. Right now they are fully unconstrained, so they are basically a full matrix together with a Boolean value per cell. So yeah, all the keys of the arity are there, and there's a Boolean value per cell. we are going to get a lot of mileage in the future by restricting the possible variables a priori. Okay. What I mean a priori means that when we build the relations, they have some constraints are known. So some values are known to be false. There is at least this, or at most that. A good way to obtain such restriction is with types. If I have two types of atom and I have a relation, like I'll have items in places, and I have a relation from item to places, and I will never have like everything that has a place in the first argument or an item in the second are just not going to be there, and that simplifies. That will make much sparser matrices, and that's going to be much more efficient. We could also use the ranges of certain things to constrain, but I don't know if that's going to work. So it's probably better to put these as a posteriori constraints, which you build a variable and then you prove you add a constraint to the SAT solver that will prove that some of these combinations are not possible. I'm not exactly sure, and we have this sort of things already. Right here. So here you have this sort of ranges. You say, the power glove is in one of these. I guess these could be a priori because you can kind of see that there are connections. Like you see, you can already see from the get-go that I'm not going to assign the B key outside of Eastern Palace, and therefore all these things, they can be used as restrictions. I think that's more or less. There's something like this in Cod and Alloy where you just define sort of constraints on the ranges, and I think we might just understand these, which can be pretty significant restrictions. In this case, you have this there's a dungeon item in a link to the past, and you say, it has to be in the dungeon in certain rule sets anyway, and there are 220-ish, I think, places in Link to the Past, but each dungeon has like the dungeon with the most thing has like 15. That would be Turtle Rock. And so restricting from 220 places to 15 is quite a reduction. It's an order of magnitude, and since a lot of things are exponentials in this, these sort of reductions are going to show up. And in that case, whatever is done a priori rather than a posteriori will reduce the compile time, which I don't expect to be the most significant bit of what we're doing, but it needs to be kept under some amount of control. So now we have an expression. So we're going to do compile expr. That and compile expr, just a single column, please. Takes an environment, an expression, and returns a relation. There's a relation. There's a let here. Equals so fun and E, and we are going to do E and action ML action, good action. Okay. So these are, I don't need this. Can I just Right, I can do this. So that is telling me this is an unused variable, which is fair. Interestingly enough, I don't have a mistake here. Give me a second, I'll be back. Yeah, give me a second. I'm really sorry, by the way. I realize I don't have a lot of adrenaline being pumped right now, and I'm a bit slow, but we should be able to do it. Okay, so the easiest case is the variable. So we have a relation. Oops, I'm going to be able to type, and we're going to have to do rel dot find r, er, I guess. Okay, that was, oops. Where's the opposite? No, okay. Rel dot find, it takes an atom list. Oh, but it's not rel, that's and dot find. It has type expr. Yeah, because that's env. Fantastic. Now we don't have an unused variable. Top takes a narity. Okay. Okay. I need to open the documentation of containers. So yes, did I say it already? We have a browser inside Emacs now. I'm not fully satisfied by how it works. Yeah, I said that. Yeah, but we won't have to deal with this changing screen. We can have the browser and the and the coding and the same things as me. I don't know why it's so big though. Okay. GI. Yeah. I don't know. There's things happen. Yeah, I don't understand very well how this is supposed to work, but now we're on the right page. I can do 0 again, possibly. We have the current API documentation. That's a bit. The key I press whenever a page is open is called reset zoom. It's the 0 key by default and current. And what's fascinating to me about this is I don't understand why reset zoom doesn't bring me the default zoom level. If someone can explain it to me, I'll be very, very grateful. I don't know what containers data is. Fascinating. Actually, it might not. I don't really want containers, do I? What I want is iter. So let's open GitHub again in hopefully a different tab. No. Yes, actually it's a different tab. Right, interesting. 0 again. let's go to Simon Kuenes's thing directly. That's funny. 0. Okay. Please. Users. This is Zoom vote. I don't exactly know why the Zoom is like this. There was something about switch to. Damn, I just closed it. Okay. GitHub.com. Maybe that will work. Yes. Okay. Oh, I just saw it. Yeah, it was something about device or toggle device. That's P. How about if I do P? I think I just killed my thing. Okay. Okay. So I don't know how this works. As you can see, it really likes to put a very big zoom, and I have no idea why. So that's the one I was looking for. I hope I have it in my my dependencies. I press 0 every page. On my API 1.2. I skipped a page. I didn't have to. Oh, the zoom looked normal. Why is the zoom normal now? I don't understand. I don't know. And so here we are. So there's an iter.map. I wonder if containers is not already editor aware. Let's have a look. Here we have the I don't know how to find something. Is slash working? No. Maybe control S works. Right. So everything that has iter in the name. So this one is iter. That gives me an iteration indeed. There's 2 iter. Oh, that's better, yeah. And of iter. Okay. And my question is, do I need to oh, this one broke. That's brilliant. Okay. No, that's not the right one. This one is the one that was broken earlier. Okay. No, that was okay. I have no idea. Yes, sure. GitHub.com/ccube. Okay, it worked. still wants GitHub to be really, really big. That's not the one I wanted to open this time. I wanted to open containers and see if I needed the thing. This one is big. At least you can read it. Oh, not anymore. That's hilarious. It's kind of easy to read anyway. Yeah, so CC map. I use map, but maybe CC map. So there's iter and there's a to iter and a from iter, I'm guessing. O iter. To iter. Yeah. So the only thing I need to change, I guess, is I can use CC map here, and well, I didn't need it on this one, but just open containers really. Can I do that? All right, now I have the containers map thing. Signature mismatch. Oh, because he wants a hash function, maybe. CC map. stlib.map.order_type. No. Ooh, that's bad. But I think it still works. That's funny. Why is it a signature mismatch? We can ask the terminal can do build. Oops, Dune build. Oh, that's because he overrides my compare function. I see. Do I have an stdlib.compare maybe? Yeah, that is quite fine actually. Okay, this is good. That's on purpose because the generic compare function is a bit risky. But right here, you know, I know what I'm doing. It's been made up by a professional. Don't do it at home, etc., etc. Okay. So now we want to get back here and look at iter. Not iter.map though. Really iter. Yeah, you can use flat map. It'd be way better with the new LEDs. Over there here. Creation. Sadly, I need to know my atoms. So I'm going to give myself a list of atoms, even before the env. That's all my atoms. Not the types. And so atoms. It's unused, but I'm going to use it right away. So I'm guessing. So here. I'm going to give myself another function. let tuples. It takes an integer, which is the arity, or the list of atoms, integer, and returns a list of atoms. No, not a list, an iter.t. Fun atoms arity. Did it just, what? That's mean. Nobody asked it. What happened? And it's not very good at detecting the type here, is it? So it's a recursive function. The idea is if arity is smaller or equal to 0, then we just return the empty list, else. That's not how the empty list is written. Oh yeah, the empty iteration, that is. Oh, the list, no. It's the iteration containing only the empty list. It's all possible zero tuple. Do I have one of these? Creation from fun empty singleton. That would be iter.singleton. Fantastic. Okay. Oh, and now it knows the type of this. No, it doesn't. I need to be at the outside of this. What happened? Add-on list to unit. That's actually correct. Not when I'm inside. Oh, and what happens if I'm here then? Oh, so I need to be in front of the hole for an answer to appear, suggested time. Well, that's good to know. I'm learning how to program in Ocaml in 2021. Fantastic. So else I'm going to do something like list.toIter atoms. So no, I'm going to, no, okay. I'm going to call myself recursively, tuples n-1. So I'm generating all the tuples of size smaller, so same atoms, of course. n-1. I'm going to do iter.flatmap. So these are fun. So that's the tuple, and that's an atom, and we return iter.singleton of a followed by tuple. It was wrong. That's definitely wrong. And that is flat map. Which could be I forgot how to do these. n-1. Oh, that's arity -1. The error messages not appearing full on screen are very weird. Like, I don't think it happened in Haskell. Oops, I just killed this. Damn. It's fine, we can find it again when we need it. It was I see, yeah. How did I do this previously? Okay, so I did that with OSEC and not with ITER. That is the only occurrence. Oh, there's sec, okay. All right, okay, I get it. Okay, I'm going to put everything on a single line. This is not supposed to close here. This goes all the way to here. Yeah, that makes more sense. Like it's probably obvious for you who's watching, but I've been spoiled by the two notation, I suppose. Yeah, I would really like to replace that by custom lets, which I'm not sure ITER proposes for some reason. Maybe no, I don't think containers has special things for ITER. So. Really? I also kill. Oh no, we have this one. I don't know why it's here. No, that's containers. Yeah. So the item one we closed. That's great. I think I need to get a bit more comfortable with this browser. Like authors of EAF, if you're watching, I'm not pooping on you. This is a great project. It's completely amazing that I can even do this. I'm just not comfortable with it yet. So here we have this solution here. Arity just gives me tuples. Arity. You don't just like in EAF at all. Well, welcome anyway. Nice to meet you. I don't know how to pronounce your name. Montezino, maybe. But nice to meet you anyway. Why are you unhappy? Oh yeah, I need the atom list. Atoms are atoms. Still unhappy? Oh yeah, and then I need to, of course, do a env dot of iter this. Damn. Ooh, yes. I need to do a map. Dot map. Yes, I'm not going to tell your boss, promise. So for each atom, think of atoms, I want to make a pair atoms and formulae dot 1. Still not good. No. Shoot. What did I do wrong this time? Let me open formula. Also, I should probably use a small one. Syntax error. That's fascinating. Oh yeah. Something is not properly closed. That's correct. No, wait, no. There's a couple of things. So that was containers. We'll need CC map. Where are you, CC map? I can't read alphabetical order. I hope this is providing entertainment because I'm really bad right now. Elevator. So it's key to A, yes. Key A iter, and we're trying to make a relation, and a relation is here, and it returns a formula that looks correct, yeah. One is of type, we can't see the type of it, but one is of type formula.t. That's quite definitely the case. If I have a formula.mli, I have no mli at all. I'm absolutely confused. Oh, I think I see it. I forgot to parenthesize this. It's still not good. What is happening? Okay, I'm gonna send the build thing going. There's really a syntax error. What did I do? Line 173. I'm guessing this one. Yes, character 4648. Oh, I get it. Oh, I'm gonna hide. I'm gonna show my face again. As is a keyword, and that's all that's going on. I'm gonna say tuple. Still not good though. And bound felt manual formula. Actually, there should be a reason to have something called formula. Still not good. No, that's not gonna work. The expressionless type, okay. Don't know why the error message don't light very well. Atom list iter. Is that declaration? What? No. I'm sorry, what? Oh, that's not gonna be very useful. Explain. Right. Atom list to formula iter.t. That's okay. That's my fault. Okay. Wow, that was a lot of mistake in one line. So, if you're new to this sort of exercise and you've never live coded before, when you're presenting, either by live coding or even presenting a talk or being at the blackboard at school, if that's happened to you recently, your ability to reason drops significantly. And you just don't see things. When people ask you questions, you don't understand them. In a way, that is a bit ridiculous. I still have one of the member of the jury of my PhD defense asked a question and I answered, and I actually filled my defense, and when I watched it again and just I didn't actually watch the entire thing, but I put it online, and while I was checking the sound, I just randomly stumbled on that question, and I heard the question, and I was like, oh, that's what the question was. I answered something completely different. And it's been a number of years that can't be mentioned in polite society, and I'm still sort of traumatized by this. Anyway, so here we have two relations, R1, R2. Oh, that's interesting. Now we need to do but we might have intersection things in containers that could help. I'm going to see what we have. So here, it's better not to stream everything because we want to do things in lockstep. So what I would like to do is to look for anything. Can I... Okay, I didn't know I had that. Okay, less, and I want to do... I'm looking for intersect, I guess that would be the name. Is there anything called intersect? No. Is there something called inter? Okay, yeah, there's printer. Really? Merge maybe? Okay. There are several. A merge, key, A option, B option, C option. Oh, that's from Ocaml. Let's look at the official Ocaml documentation then. I don't remember where it is, but metax. We're gonna open DuckDuckGo. I think there's a way to have Helm work with this browser, and that would help a lot. Okay. Oh, yeah, of course. Oops. What I want is bang Ocaml map. And ooh, that is bright. I don't know why this escapes the dark mode. Sorry if that just blinded you. I'm gonna try to find what I want to find. Okay, this I have no idea why this one page was white. It might just be a bug in the browser. That wouldn't be very surprising. The browser, by the way, is just a WebKit. It's a Chromium-based thing. I don't know whether we can add extensions. Haven't found a way. So, okay, there's merge and there's union. Union is interesting. So union computer map whose keys are a subset of the key of M1 and M2. The presence of each binding is determined with the function in terms of find opt operation. We have find opt merge. Right, since 3.12, I'm way ahead of this, and I'm ahead of that one too. Okay, so we're just gonna use this, I think. The merge safe looks good too, but it's just more annoying, I think. Well, actually, it's not bad. So let's call this one, I guess. It's kind of clear what's happening. There's a bug down there, and I have no idea why. I'm guessing it's just a consequence. Maybe I added something. No, I don't know why there's an error happening. We hope that disappears later. We can do map.merge safe. No, it's not map. It's rel.merge safe. Yeah, so sometimes it happens because I have a modal layer on Emacs, and sometimes you use the command mode or normal mode because you think you're there, but you're actually in edit mode, and then there's some random characters appearing somewhere in your file, and that's the most common way. But that doesn't look like it because it just creates gigantic syntax errors. So we have a function here. We have M1, R1, R2, and that should have the right type. Ooh. Oh yeah, it's compile expr, of course. Compile expr. Same atoms, same env. Compile expr, same atoms. Why does it feel? I don't understand that. It just feels. Why does it do this? What decides that it can take? Like my computer suddenly not. My Emacs is not configured to be allowed to just go back during a line of code. Either it thinks that it's in a comment. Label F was omitted. Okay. Oh, I can use the label. That's quite clever. Oh dear, don't do this. Well, actually, I'm what is happening? And so we have and just avoids a special case, though I guess that would have worked just as well. Actually, these two are the same. Why is it not happy? Yes. Oh. Is that the problem? No. Sure. Sure. Rel key atom list. Oh, I just forgot a particular. Oh, I closed it again. Okay. I don't think I need the tuple actually. I don't care. I closed my documentation. I don't have this. There's no way to call it back easily that I know. So a plea in chat, by the way, if someone knows how to use the EAF browser, just do tell me. I'd be very, very happy to know. So both left and right, we just don't care. It's an intersection. So both of these will return nothing. That's null in Ocaml. Okay. I can just put it in a single line, I guess, because it's short. And if both are true, I'm going to return the conjunction. So here I have two things. I have formula 1, formula 2. And formula. So we want to say formula dot F1 and F2. Fascinating. What's the problem? Please help me. Okay. No, there wasn't one. That is quite correct. Yes. Is that type correct? Okay. And the error below has disappeared, I'm pretty sure. No, it hasn't. And I haven't. I don't know why that would happen. Did I? Oh, I think it's because that's the problem. It must import something that has a name that I'm using. Well, we'll check it. We'll check this out in a minute. I'm gonna make a whip commit though, because there's a lot written, and push it to GitHub so that even if my computer bursts into flame right now, we haven't lost this. If my computer bursts into flame and several data centers in GitHub burst into flame at the same time, then I guess we still lose it. But I guess I'm taking this. So here, same R1, R2, So what is left? This one. So we have the union function. Which is a case where we only... Oh. Ali union is intersection. Okay, I'm not going to call union because it does exactly what I don't want. I'm going to call merge again. That's scary. So we should... I'm going to add a note, an XXX, I guess. Note that union and intersection below to preserve the invariants that all keys have the same length. Need to apply to relations with the same arity. It would probably be healthy to do a pass of arity checking on the on relation expressions. Just as a way to debug, I guess. So we're going to use merge again. We'll use the same function, except that everything will be different this time. We still don't need the keys. I'm gonna need something here. Here it's clear it's disjunction. So here it's supposed to be an option, so I want to say sum. And that's quite easy because that's F1, and now we want F1 here. And here it's going to be the same but symmetric. I could do that in one line, but I feel that they might in theory have different things, types. I guess not, but I don't really like this. So that's, why we're seeing this is conjunction with false is false, and also I should make a slightly different of either. So I should it's of either. Maybe we should have an expert module. Interesting. Elviter, so it takes an expression. No, not an expression. It takes. Well, it's a rel. Okay, we have. We should. Okay. Should really be in the rel module. Yes, that's Ocaml language server together with LSP mode on Emacs. So the telltale thing that says it's Ocaml LSP, it's Ocaml LSP actually. There's kept a couple of these, I think. And the telltale thing that sees that there's LSP running is these breadcrumbs here. When I enter in the functions, oh, here it's just, I should remove that for it to work, but here's, I'm in in directory source, in file datalog.ml, in module arrayalg, in function compile expert. This only LSP does. But what it's also doing this printing of error messages on the file, but they're misaligned and they're out of the file. I don't understand why. So, but I mean, it's going to get better as the thing gets released more often. It's also maybe an old version, possibly, because I'm using an old Dune fork, and maybe it's not, the last version is not compatible. I don't know. Not Dune fork. I mean, like an old Ocaml switch. Like random words are getting out of my mouth, and that doesn't make any sense. So here I want to so an atomlist star setvar formality iter.t, and I want to return a relation. And the way we do that we do that by doing rel, so I need a function, so fun pairs, key value pairs. Why do you do this? And why does that? So I want rel.oviter like normal, but I want to filter out every false. So I want to say iter.filter. So we're going to make a filter. We're going to call it not false equals function formula dot zero is false, else is true in. So we filter not false in pairs. Okay, sorry, that's true. Here we go. We should probably make the formula. So right now I'm using formulas, but maybe I want to actually use bona fide BDDs. In CodCod, they use some kind of compact formula representation which are not BDDs, but you know, either way. So x66, they don't want to use formula actually, but by BDDs directly. It's not a very big refactor. One of the good things about using BDDs would be that we could like there would be much more zero things. Because here you notice that these are not really smart constructors. I mean, we're just being very, very simple here. So the good thing about BDD, if my function is equivalent to false, it will be false, and that's quite a bit better. And if we have a bunch of BDDs too, it's decently possible to generate fewer expressions, I suppose. Well, I guess we'll just BDD things for generation, but anyway. Do I have a formula that's a BDD thing? Maybe not. That doesn't appear to be. I probably should have one here, because it's just fairly generic. So there's a lot of utilities that I'm missing because I'm doing this, you know, pretty top to bottom on stream. I don't want to. It's quite funny. I don't know what head is. I think a Ocaml container is messing with my thing. I can fix this by not importing container or changing a couple of names. We'll figure this out. Okay. Anywho, where was I? Right, and okay, so here Oviter is easy. It's better. Because here we should also 666. This could be the right, and that kind of matters for efficiency. Cross product. Here it's R2. Actually, what is it? So here we want to generate like R1 followed by R2, which I don't remember how you write in Ocaml. List concatenation, is that at? I want to say it's at. I'm not sure. I want to say it's at. Might be. So you want to write R1 followed by R2. What is the associated formula? So the idea, if you only have true and false, the idea of this, if R2 is false, then we don't include either. Okay, so I think at is either string concatenation or list concatenation. But I want to say that at is list concatenation and string concatenation is the caret symbol. That's my guess. Anyway, I don't think I've done any Ocaml in 2020 at all. So this project I did in 2019. I'm getting back to it. So I'm derusting my muscles, my Ocaml muscles a bit. I usually my day job when I do programming, I program in Haskell most of the time. And I've been like 2020 I spent doing a project in Haskell as well on stream. So it seems to indicate that it would be conjunction. You need both to be selected for the big tuple to be selected. Is that correct? Yes, I am fairly convinced. So that's what we're going to do. First, we're going to pour some tea, because there's never enough tea in a mug. I'm going to try to not pour tea on my keyboard. This has backfired before. It's pretty late here, so clumsiness. I take it away from non-strictness. Yeah. I mean, strict or lazy, I don't think anyone makes the biggest differences. Part of the reason why I'm doing this in Ocaml is because there are some there's sort of exactly the right Ocaml library for me to use to interact with sat solvers. Well, there's really a sat solver called msat that I'm using that has been written in Ocaml. It's pretty easy to deploy because it's just, you know, Opam installs it. It has functors and all the jazz, so it's fairly easy to integrate in a project. The other thing I do in Haskell for reasons, because I wanted to use some fancy types. I'm not sure I'm using any fancy type anymore, actually. But the Haskell has quite a more advanced type system than Ocaml, for the better or the worse. And sometimes I kind of like it. You can abstract over a ton of things in Haskell that is a bit more clumsy in Ocaml. And I think that's pleasant, to be honest. You have purity with its pros and its cons, and yeah, laziness. Well, like for this sort of project, laziness will just not be a problem because it's too small and it's not where efficiency is lost. In real life, sometimes it bites you pretty hard. I actually gave a talk recently about that. It's on the Skills Matter website. About the like when you would rather have one or the other. But to be honest, most of the time it doesn't make any difference. It's kind of the most important lesson. So yeah, it's one of these skill casts that Skills Matter has on the skills-matter.com, I want to say. It's not my best talk, I'm afraid. But I kind of like researching and giving it. It was a very interesting topic to get into seriously. It's very easy to troll about this subject, like Emacs versus VI and all this sort of things. It's fun, it's entertaining, but it's not very constructive. And we're trying to consider it from an actual engineering point of view. It's been very, very interesting to check out, to try and research and say something smart about. I'm not sure I've succeeded, but anyway, we know what we want to do here. So we want to compile expert. Oh, very good. Atoms and R1, and the same thing again for R2. In both of these, we want to. I'm going to put them on 2 different lines. Should have. Oops. And both of these we want to rel.toIter. Now that we have this, we will want to do iter dot Cartesian product. No. How do we want to do this? There's several ways to do this. That happens to be a Cartesian product. There's actually, I could have used that. When was that? Earlier. Okay, there's something happening. Fair. Well, I can do what's happening exactly? I don't know. Let open iter in. So we can do this. So here we get tuple 1 and F1. And then we do here fun tuple 2 F2. Stop doing this! Why is it doing this? I don't know. Now we have, I want to return. Return, does that exist? It exists apparently. Return tuple 1 at tuple 2 colon formula dot F1 and F2. That's not going to have the right type, because what I want to do is of iter begin end. Really? That's the right type. Then if I okay, that's a fair way to write this. I'm fine with it, with this indentation. So here we go. That's actually better than what I wrote the other place. I don't remember where it was, but we're gonna here. I can just do this, I guess. Excellent. That's quite a bit more readable. Why is that unhappy? Oh, because there's no... Fair enough. Same are going to be filtering things. So what are the order arguments? That's an int, and that's an expr. So I1, I2, and R. Here we're gonna have to compile expr atoms and R. When I write these sort of things, I wonder if we had like this you know, rel not being parametric, but you can change the recursive type and you say, oh, I can write this and just assume that I have compiled some expressions everywhere, so I don't have to compile this. And I take the fixed point, you know, the open recursion sort of scheme things. That would be quite a bit better in many cases. But we don't really have good syntax to make that palatable, which I think is a bit of an issue in a way. Not an issue, but a pity, really. So we'll have this thing where we're saying, oh, we have to repeat, compile, but really there's just, as Haskellers like to say, it's just catamorphism. But there could be a very nice way to say that by just saying that we just, you know, we write as an algebra. So rel is a functor of sorts, and we say, oh, we want not rel, expr is a functor, and we want a rel expr. So, you know, not the recursive one, the generic one. And we say, so whenever we see a recursive thing, it's already compiled, we just apply the thing recursively. And then we just say, oh, when we have a rel expr, we actually have a rel. So, well, in function, we kind of have an expression from a expr to a, we have an a. And we could do this, but that would require changing expr to how to support that, and then everything become quite a bit unpleasant. If there was some, you know, compiler support for this sort of things, it would be fantastic. I think there's so much that could be gained by having some like built-in support for this sort of reasoning. Like I could just write expr, and then I could have this expr prime defined for me, and expr prime would be a functor, and I don't know. Anyway, so here, this will also be rel.toIter. We'll also have to call of iter at the end. Okay. Right, so we're taking an iterator of these, and we want to do some iter.filter to this. What's the type of this? Right, we have an atom list and a stat var formula. Oh, we don't actually want to do a filter. Good Ocaml RFCs are great. that's like, okay. So I've written a proposal for GAC, and as far as I can tell, RFCs for Ocaml are a bit the same sort of things. And like, I don't have a design anywhere near precise to be able to do this, and I don't have an idea what the implementation could be. Maybe in 50 years the word would be so much better. When I think about it, like programming 20 years ago and programming now is very different in experience in many respects. Some because of how languages have changed, what we expect of languages. Some about the tooling, some about the ecosystem. So much has changed, and in 20 years it's going to be very, very different. Maybe there will be a way to do this sort of things in every languages because someone very clever has figured out what it should look like. I'm looking forward to it. That will be brilliant if it happens. I like to talk about bridges because bridges are brilliant. I think it's quite amazing. But okay, okay, not all the languages. Okay, I get it. Java 7 doesn't exist 20 years ago though. Anyway, yeah, bridges. Like the first bridge is probably as old as Homo sapiens. It can be like tens of thousands of years ago. There's probably like 3 ropes thrown over some kind of chasm. We got more sophisticated with time, and to the point where we kind of built the Roman bridges, like these very massive stone bridges, which are basically a gigantic slate of stone across a gap and with holes in it so that you can pass another road below. But it's just very massive, very heavy. And in the 20th century, we got to the point where we could make something like the Golden Gate Bridge, like these suspension bridges that are mostly air. There's nothing there. There's no mass at all. It's absolutely fantastic, amazing. And to get there took tens of thousands of years of accumulated knowledge and understanding. And if you think about the last 2,000 years, like from the Roman bridges to the suspension bridges, we learned a lot about physics in the meantime, but that's not really the big difference. The big difference is we broke a lot of bridges, and we started understanding how we can break a bridge. And so what is the question I need to ask if I want to make a bridge that doesn't break? And it can make them lighter and lighter because I know what the questions are and not what the answers are. Well, the point is, it takes a lot of time, and programming is an activity that's less than 100 years old. It's extremely young. So we are the babies, whether the rope bridges or maybe the Roman bridges at best of programming, and few generations after us, the word will be so extremely different, and they will think about the way we programmed in the 21st century, early 21st century, as completely archaic. And well, that's sad that we're living this word, because I'd like to live in a world where everything is easier than now. But on the other hand, it's quite like, it's very like, there's an optimism to that. It's fantastic to think about how much better the word will be after we leave it. Like we will leave the word in a better place, hopefully, and it's going to keep getting better. Yeah, it's a good analogy. Also, bridges are really cool. I mean, like, if you think about it, like, it's amazing the suspension bridge actually holds together, but there's something even more amazing is there's a point where the suspension bridge is not finished and it already needs to hold together. How does that happen? I know partially the answer, but that's quite amazing. The amount of engineering that goes into bridge is just so fantastic. Anyway, let's come back to this. So we don't actually want to filter this thing, I think. Oh, that's really interesting. So we don't want to filter because we don't know whether oh yes, we do, because it's just about atoms. Yeah, that's good, good. So we filter on atoms. That's fine. We don't change anything about the formula. Great. Okay. So we have a list of atoms here, a tuple, and we have a formula. And we don't care about the formula actually. So we do something like this. And we know we can take equality on atoms because they're integers or they're strings. It's fine. Where were we? Yes, we need to index into lists. I think I've got the hiccups. I think Ocaml has this built in. So if I go up and I go up, I find list here. I'm using my mouse. This nth, that's fantastic. So list dot nth. I1 tuple equals list dot nth I2 tuple. Oops, dupe. It's not happy because right, containers that equal. What happens if I do string not equal? I think it's, oops, I think, no, yeah, okay. So I think there's an equals function. Equal, okay. That's funny. It falls back as this sad var equals in, so it sees an inset. Oh, it's a sad var. Arguments in the wrong order. Okay, that's gonna be no. That's gonna be fine. Okay, I was afraid that the 2 would stay in place. Okay. Just leave me be. Okay, so that's the same, and ecatom is the same thing, but just a slightly bit easier. So we have an I think that's an I, yeah, that's an A, and that's an R. We do the same thing here. Oops, let's just go here. Fantastic. Now we don't. We just have an I, and we just check that it's equal to A. Boom. Is that beautiful or what? Now, proj is more interesting. But also have to do with an oviter. It's very beautiful, thanks. The truth is, I don't know how to do this if we have intervals of true, as was done before. I'm not sure what I'm supposed to do then. And whether it's worth it. I don't know yet. So I'm wondering about that. And for the record, yeah, you can know that's the way, if you have a sparse matrix represented as a key value pair, as a bunch of key value pairs like this, is exactly how you will do a multiplication. You will get these two things. Like suppose they're tuples of size 2, that's going to be easier, and then you just combine them when the k. Oh, I just realized something. This is the wrong item. I'm going to get back to this in a second. So you whenever so there's this is so you just read that as this is a pair ik, and there's a pair kj. So whenever the two k's are the same, then you combine them and you emit them back. But I forgot, and I'm going to do right now, is this is not correct, because of iter, I think just if I have several times the same atoms, then I will just ignore one of these. And what I want to do is accumulate them. We're going to go back to containers. I just closed this again. Great. Yeah, this one is dead. So let's kill it. Yeah, so whenever I press X without control, I kill it. It's kind of unfortunate. Browser. Getup.com. I don't know how to access the history or anything like this. The dog is here. CC map. So provider, add iter. Yeah, it does like overlist, and overlist builds a map, added. Only the last binding, yeah. So overlist, add list, keys, value. Really? We don't have a. I'm going to complain. Give me a second. Okay, sorry. I had to ruffle some feathers. Okay. I have to think. I guess I can just implement it because I think that add iter or this like my guess is that defining of iter is not very hard, so we can just copy the code of this and just change it to little. Ocaml key update. There's update. Update is more or less the function that we want. The fact that this function is called union is still shocking to me. So update is the function. So overlist uses add, and I think we kind of want to use update instead with some, combination function. In our case, it's disjunction. We're using disjunction as the matrix sum and conjunction as the product, I think. Yes, that's what we're doing, quite definitely. It's semiring, it works. Like any semiring can be used to make a matrix semiring. It's the theory of this is pretty elegant. Yes, I don't think there's much else to say about this. We're gonna have to do this, but to do this, I'm gonna go and grab the implementation. That's not what I wanted to do. Read X. So get a. It's quite fortunate that I know how to find this thing. I'll have to get better completion support. Source is a fuzz module. Fantastic. A call. CC map. And we're going to look for of iter. That's not going to work. So I wrote something else. Right. I'm not sure why it's duplicated. Add iter of empty, and here we see add iter. See, it's a very simple function. So what I want to do of iter. So we can ignore the filter thing. It's fine. So this is, it takes an iter. So yeah, key value pairs. And S is, what is S? Oh yeah, that's S is what I'm gonna use, yes. So let m equal ref rel.empty. That's all false. Start there. Oops. That's company being funny. And we do call kvs fun kv. It's continuation passing style ish. And colon equal. It's very imperative, this code. Rel.update key with I'm going to call it combine v. I'm going to define combine in a second. And bang it. I don't know what happened. Oops. Bang m. Now return bang m. And I need combine. Combine f this function. So if there's nothing there, then we just return f. Some f. We're going to just return sum all the time, and if there's some f prime, we return some formula dot f prime or f. That's interesting. It takes an expr from that option. Why does it take an expr? It shouldn't take an expr, which is a formula. That sounds like a completely wrong thing. Okay, let's go back to the terminal and ask to build, because I don't understand. Expression of type expr, but expect expression of type alpha t. I don't even know what alpha t is supposed to be. And that would be line 185, 43 to 51. What? There's no character. Oh no, sorry, 40 to 41. I was reading the wrong thing. Right. So why does it assume that this has? I'm a bit confused. That's a Sadvar formula T by definition. I don't understand. I should also do so I don't know why this doesn't type. I have to think. So there seems to. So I can really strongly believe that f, an expression. Oh, is this because I have two things called f, eh? No. But there are really no expressions in this thing, and that is supposed to be a formula. That is an expression. That is a formula. Why? And that or is 80 to 80 to 80. Okay, 80 is formula, right? Because yeah, because it's in there. Okay. So I get it, but I don't get it. It tells me this is type expr. That makes no sense to me. Maybe it's because okay, there's something that went wrong somewhere. Not happy about this. Yeah, okay, because it's not rel. Okay, that's fine. Okay, that's the type I expect it to have here. That is not the type I expect it to have at all. Why is this? Yes, atom list, that's good. Let's type this. Alpha ref. is not super precise. So it doesn't know the type of this, or it doesn't know how to display it. I am extremely confused right now. And when we see the thing, or when I see the thing, eventually, I'm probably going to be very, very much ashamed. Right now, I don't see it. I don't see it yet. Pairs are here of iteratives. Why does it want it to be? Is the type of combine? This is a very weird type to choose. Says that has type explorer, and combine returns a formula, which makes no sense because it's supposed to return sum of something. Is update the right type? Because maybe, yeah, it's option to option. What's happening? I'm very, very, very confused. I don't know how this type could possibly be inferred. I just poured some tea on my shirt. It's all fine. Let's combine f equals function on to sum f. List version to rel. Oh, this is what I expected to be. There's something insane going on. Let me just add type annotation, because that's easy to do actually, and we'll this is going to fix everything. This is pinpoint the problem. I should have started with this. So combine takes it was a formula. A set var formula t option, no, it takes one and return the set var formula t option to set var. I can't type. Okay, and so Matt. I'm confused. I well and truly am confused. Do we add more type annotations? Probably. to rel actually, so that's fine. Rel equals fun. I'm going to wrench everything in a second. Okay, so now there's something wrong. We found the bug. I had forgotten a semicolon. I hadn't forgotten a semicolon in a long time. My Emacs is holiday themed. Hey David. It's the same Emacs as last time, I think, and the time before, and the time before that. The colors look nice. I hope they do look nice. It's part of the collection called Doom Themes. This one is called what is it called actually? I don't know. It's my dark theme in my dot files. You can find it. There's a large collection. I find that in the Doom themes, the dark themes are quite, on average, better quality than the light themes. I still haven't found a good light theme to replace my own when I use light theme. So we can remove this. Well, if you do, this one works. Writing nonsense. I don't know how it's called, but I can find it for you. I use light theme mostly when I have glare or when I'm outside. So during the summer, I use light themes a lot during the day. That's funny. No, really? The semicolon is here now. This is insane. How does it possibly say that? Is what Dutch, sorry? This is pure insanity. The Flying Dutch semicolon. No, that's not it. I have non-recursive functions and I remove type annotation. It starts inferring completely random types that have no connection whatsoever with anything we're seeing in this function, and I don't understand why. And I don't want to spend any more seconds understanding why. I'm just going to comment this for a short while. Okay. Okay. If I don't change anything but remove this type annotation, what happens? Still good. If I remove this and write equals here, still good. If I remove this type annotation. Principal types, eh? This makes pretty much literally no sense. I have absolutely no idea how this could possibly do this. I found like this feel that it can only be a bug in the compiler somewhere, which I'm not going to investigate and probably has been solved a long time ago because this version of Ocaml is 2 years old. Anyway, let's do the projection thing. So David, what we're having here is like relations which are represented as sparse matrices of tuples, well, sparse like tensors, like they're multidimensional matrices where the values are Boolean expressions because they can have variables. And so we see that as just we have a list of key value pairs basically for each of these. And yeah, whenever we have several, you know, whenever we combine things. So anyway, the general idea of computation is we tend to turn this. We have a finite map that is represented as a tree. You can think of it as a hash table, and we generate all the key value pairs as a stream of data. We do some stuff to it, and then we get the key value pairs back. And if we have two of the same keys, we take the OR of two of these. That implements existentials and so on, and that's what we're going to do now. So we're going to do. I've got this thing that has a number of possible like tuples that have a certain dimension, and we're going to project on some of the dimensions. And I think that the first one is the dimension. Yeah. It's a list. Oh, yeah, it's an list. Okay, so that's the indexes. Well, have a good afternoon or evening. Thank you for joining. It's better to have someone to speak with and to share this with. Welcome back whenever you wish. Where was I? It's not a tensor of tuples. It's a tensor, like an n-dimensional matrix represented. Well, I mean, you can think of it that way anyway. It's one way to think about it. Represented as a mapping from n tuples to values, and the values happen to be Boolean formulas. Yeah, it's a sparse matrix. Yeah. So that's the. We don't I don't do multiplication because I don't really need it, but you can get multiplication using the cross product that just really is, I guess, is a sort of tensor of tensors. You just add up the dimensions and same and proj. Like we need 3 constructors for that. The same says I'm going to it's going to say, oh, if I see the matrix as a relation, and the relation is just predicate on tuples, I'm just going to take these tuples that have the same value on I1 and I2. So it's not a very non-matrix thing to do, really. There's like several concurrent views, and we just alternate between these. It's a language that is very common in at least in the theory of databases. That's sort of where I took my primitives from, but it's also directly what I use to compile. So the idea is that I have datalog programs, and I compile them to these relation expressions, and the relation expressions I compile this sort of matrices that are then lowered to a sat solver to resolve and see which variables can hold or not. So here I think it's going to be fairly systematic. So we start with an of iter. Begin. So iters are streams of these. So now we also take. I need an end. So I will compile expr Where am I going with this? Yes, atoms and R. I'm then going to do rel.toIter, and then I'm going to do what? Then we're going to do a map on this. So I know the map. There are simpler ways to do this, but it's fine. So for each of the pair, so we get a pair, K, V, and K is a tuple. We should just call it tuple. And that is a formula F. And we're going to just return F with a different tuple. Here we have a hole that is of type atom list, and we want to project. And we want to okay. So the idea is that we do, there's a map. We're going to map something on i's. So for each index, and for each index, we're going to just take n list.n, which we have n written somewhere. Okay, so I can do list.n of tuple. Boom. So what we're saying is this is a list of dimensions in a certain order, and I'm going to take a matrix there, and I'm going to just project it along each of the dimensions. If I see that as a predicate on tuples, I'm just going to reorder every tuple and drop a bunch of the values, and then I sum up together things. And summing together again is taking the disjunction. If either of these one exists, then of the original exists, then the final one exists. And that's almost all I wanted to do today, so I'm a bit early actually. So we also have a notion of formula here. Oh, I get it. I just figured out the problem with it, just because I called this sum because it's called like this in Codecod, and it interacts badly. What is RA? Nice to meet you. Define null 0 or null O. Is it a no or a 0? A relational algebra. Okay. Yeah, that's exactly what it is. That's a 0. Define null 0. That's funny. Yeah. So what are we doing here? If you're just joining, because I'm early today, I'm just going to explain what's going on. So my ultimate goal is to be able to say, so it comes, we don't have a direct bow tie operator. We have a cross product and a same. Where are they? I lost my AR. Here they are. So that's a cross product, and that says just same. So cross same plus proj will give you the bow tie operator. So why are we doing this? So at the end of the day, what I want to do is to be able to generate random shuffles for randomizer games. So in a randomizer game, you have a bunch of things that can go in batch of places. That's the simplest case. So the one I usually play is a link to the past randomizer. You have chests, you have objects, and objects go to arbitrary chests randomly. However, you need to be able to complete the game. So there's this thing called a logic. And I want to, well, I didn't want to do that. I wanted to, open the logic. Yeah. And so you want to be able to specify rules saying, to be able to reach this place, I need to have this and this. And at the end of the day, I want to say, there's a goal, in which case that I just specify desert boss, and I want to say, this goal is actually reachable. So there's this called randomizer implementation is called datalog. It's the rules that let you complete the game. I want to be able to specify this in a very declarative way and then generate a shuffle. So the observation here is that these rules, and actually there's some implicit here that we want to add, really amount to a datalog program. Where you have there's a bunch of things missing, but there's a database that just says which object goes where. But I don't really want to have a database. I want to generate an instance of that database where the goal is true, or the goal is reachable. That's the general idea. And so I'm using sort of fairly standard techniques to compile datalog into relational algebra, and then relational algebra using into sat solver expressions. And then the goal will be to use standard methods from sat solvers to generate random models to be able to generate a random shuffle. I had a previous iteration of this, of which some of which I will keep, which uses a much more ad hoc way to lower to sat solvers that doesn't let me have full datalog, which was a bit unsatisfying. It was very ad hoc. It was very and so this is a generalization of the same idea. There's a lot of documentation in this file. This is the branch datalog. We can't see it, but it's the branch datalog on the repo. You can do bang repo to find the link if you want to read on this. There's a link in particular to a paper called CodCod that explains how they compile a different but similar relational algebra to SAT. The paper I find is a bit hermetic. I had to ask questions to experts of the domain that know a lot of the implicits in these to understand the details. But there's a lot to unpack there. But it's a pretty nice paper nonetheless. It's just very brief for the amount of data they're trying to get across. So that is the master plan. That's what we're playing at here. So relational algebra and datalog, of course, are related to databases, but I want to sort of invert this usual view of things where you have a bunch of facts and you want to prove things or to extract derive facts from them. The facts are the database or the content of the database. And in that case, the facts don't exist. They are generated. And that's why we're using a SAT solver. There are other instances. If you look at datalog SAT solvers, you're going to find some things like mu-z, which is a Z3 offspring. But that's a bit of a different thing where you try to prove things using at least partially some datalog thing, and you use SAT solver as an engine to solve datalog problems or something. I'm not super familiar with it. So it's this entire domain, like it is like all the bricks exist more or less. They're put together here in something that I think is a fairly original fashion. I didn't say so. I have a way right now to generate a uniform like random shuffles that are correct. But for that, I generated sort of I compile the entire logic into something called a zero suppressed binary decision diagram, or ZDD for short. And they get really, really big, and it's very, very slow. So since then, I've found a way to generate approximately uniform random models of using just a stat solver and not compiling, and it's part of what I want to try in the next few weeks and month. Like, it's a project until maybe the end of spring or something like this. I should be done by then. So right now we're just compiling relational algebra, assuming that we have values for everything. But what we want to do next time is to start thinking about recursion, because a full datalog program will have recursion in it, and we will need to be able to does that happen here? That might happen. Well, it doesn't happen obviously, but some of these rules might, there's several ways to go. So you might need to have desert bars to get to Eastern in a certain way, or to have Eastern to get desert in another way. So you have this sort of recursion thing going on, and I have not supposed that. The easiest way is just to iterate something, but I still need to do the code for it. And yes, so I wanted to code sum, but I want to change the name of sum now, because that was a pain in the butt. Explains a lot of things. Right, it was telling me. Okay. I got I got confused by something. It's fantastic. So I'm going to call that exist sum. Did that break anything? Where did I write sum in this? So that's okay. Right here, there's no problem really. Okay, we'll see later. We might change our opinion. Oh, did that unbreak everything? No. There's a few bugs here because I opened something. I don't know what this is about, and I don't care for today. I think I should fix it off stream. Probably it's not interesting. So yeah, we wanted to do compile formula now. Let compile. Oops. So this takes a formula, and that returns sadvar formula.t. It's not a complete coincidence. I'm thinking maybe I don't want to actually. I said that at the beginning of the stream, but more people are here now. So I don't think I do want to keep with formula here. Eventually, I think I want to have BDDs instead. But there's a bit of complexity here in that you have to initialize a manager and so on and so forth. And the idea for that is because BDDs reason up to equivalence. Whenever I have something false, it will disappear from my thing here. Like not false here would be much more precise because it will just detect anything that is equivalent. Like any formula that will eventually be equivalent to 0 will actually be 0, so we can detect that immediately and we can just drop them. And that might yield a fairly reasonable formula. And I'm pretty sure I have a compiler somewhere from BDD to stat formulas, so they should be quite fine. And that uses like a bunch of normal things like state forms, stating transformation, and so on and so forth. The only thing about BDDs is that they're if then else's, and that's a bit verbose. It's all right. It's not the best. You might have a bit of verbosity included there, but on the other hand, because everything is very, very compact, you can generate very, very compact formulas. Because if you have several things, you don't have to expand the entire tree. Anyway, I'm babbling right here. and now it doesn't really function. We want this function, and here we actually do need an and a list of atoms, I guess, because we need atom list and anv. Okay, so I'm going to change that. We're going to do fun. Why is it doing this? I don't understand why it's constantly breaking my lines. Did it always do that? I don't remember. So atoms, anv, and that's the formula. We'll call it F. And we're going to do this again. MLA A. Right. Still going to break this. So here we have something of type expression. We're going to call it R, and we are going to compile R, of course. So compile expr atoms and R. This is not used. And this takes a relation and returns a formula. Right. And so first thing that we want to do here, actually, so we're going to do this. I'm going to compile. I'm going to, that is nice. I'm going to do rel.toiter. So that's exactly what we want. I don't actually care about the keys, but we have an iteration, a generator of keys, of pairs of keys and formulas, and we're going to basically take the disjunction of all the formulas. So let me get back to. Okay, I don't have it anymore. So github.com cq either, I think. Still gigantic. Oh, actually, oh, I found it. H, okay. HW, oh, it was already interesting. So the Aces version, I don't care. A. Okay. So what I want to do now is consumption. I want to fold. So is that what? Okay. Okay, so I'm going to actually map. Does second exist? Right. Okay, so now I only have formulas, and now I can do either.fold. Oops. Okay, that's unexpected. Oh, I need a seed, don't I? Right, I need a seed. The seed, of course, because I'm going to take a disjunction, is formula.0. Okay, and that takes a formula, so that's disjunction. Bound. So what is this? We'll just this is a test that a relation seen as a matrix sparse matrix is not empty, so we iterate. So we first take there's syntax, so we just compile the syntax to a semantic relation. Then we say, let's get all the tuple formula pairs. But I don't really care about the tuples because I'm just trying to say, does there exist a tuple in there? So I just take all the formulas that I get, which are all the non-false things, and I got all these formulas, and I just take the disjunction quite violently of all these possible formulas that I have, which also show that I really want to have as sparse matrices as possible. Otherwise, that's going to be a big formula, but it's expected that it's going to be a big formula anyways. So I'm just finding very, very big formula. Another thing that my ad hoc thing had before was that I could sort of debug what was happening, and here, that's kind of what I'm scared about. There's no real way to observe that I'm not doing nonsense. It's going to be very, very interesting to debug. But yeah, that's the general idea. Now we can compile a bunch of rules here. We can compile the goal into a formula, and we can probably like pull this together and compile an entire program this way. Sort of, because I haven't done any bootstrapping, but I'm too lazy to do it right now. I would need to there's this thing here. I need to. Everything that would correspond to the instance, to the database from Prolog. Everything. I need to generate a relation for in the environment that is full and has plenty of variables, and I don't know what to generate. Well, I have sadvars, but I need the ability to create a new variable. I can give it to myself, I guess. But anyway, I can pull this all together. It's not really. I guess I can do this. Let's do the initialization. So I'm going to take a declaration list here. And return an environment. That's my initial environment. So it's a placeholder. New var equals. So we're going to do the normal thing. Let c equal rev 0 in one unit to let r equals bang c in inc c semicolon r. Oops. In so right. So we're going to take the declaration list, fun, decals, and so we're going to do decals. I hate when it does that. It's very enthusiastic in its reformatting, I guess. When I don't need to, but when I need it to say, oh, that's not what I meant, it takes a while. Or I need to do it manually. It's kind of weird. I think it's just the first character of every line, but it takes a weird thing for the pipe because it thinks it's a match thing going on. Anyway, no more ramble and finishing this. So I want to do list.toIter. Now I have an iterator. Now I can do either map I'm going to call a function called initDecl that generates thing, and then we just need to do and of iter. Right now I'm just missing another function. Let initDecl. It takes a declaration and returns a pair of the declaration, which is itself, and because that's what an env is, yeah, and a rel, because that's what I need, equals fun_decl in, and so for now we don't have any bounds. I'll edit this. We might also want to, yeah. To do, can I keep a reverse mapping var to tuple star declaration so that I can print meaningful feedback. And I say can I'm pretty sure I can, I just need to do it. So that's a pair of a decl and new rel equals so new rel, we take all the tuples of arity decl dot arity I need atom list. I do need my atom list here. Yeah, that's definitely the case. Here I need atoms. I should not do this. Really? Okay, so this is okay. This takes we have a bunch of things, and so what I want to do here, I want to use something like, you know, I want to abuse Ocaml a little. So either .map, we take a tuple, and we return a pair tuple new var. And so that doesn't have the right type. What I want to do is Arbeiter. And then value. Oh, sure. It is definitely not happy, but I don't know why yet. Oh, it's not new var. I need to do new var this, I need to do this, and I need to do var. It's not var. For sure it's var. It's var. Okay. Okay, I'm gonna manage. Okay. Type declaration. $203. Here I am. And 52. Okay. Oh, right, that's not the right kind of var. Yeah, that's because I'm an idiot. It's not this what I want to do. What I want to do is a formula. Formula, so I've got a var in formula 2, but it's not var, it's formula.var, of course. Okay. Because the var here is a variable of for a relation. So here we go. So what do we do? Sorry. Right, so what's happening here? So when we create this thing, we want to generate an arbitrary database. So we have a bunch of relations, and we want to fill them with arbitrary tuples. And what we're going to say is, so we have a finite number of atoms, so we have a finite number of tuples for each of these relations, and we're going to brute force this by saying, like, for each possible tuple, that's what we're saying here. So we take all the tuples of atoms of the right arity. So the arity of the declaration. So if say I'm a relation of 3 atoms, then I'm going to have all the triples. And so for all of these, I'm going to generate a new variable. And this variable will mean, this variable will actually mean this tuple is part of the database, of the table. So each relation is a table, so the tuple is part of the table. And we're generating for all of them. Though what we're saying here in this particular comment is, well, I mean, that's a lot, and we might want to be able to put some restrictions like of non-logical nature, like very easy syntactic restrictions on the relation, so that a lot of tuples are just not possible by construction, and that will make much smaller search spaces. Yeah, that's unrelated. Okay, and so for each of this, we generate a thing, and we just say, okay, I'm going to store this. So it's a sparse matrix that is actually 4, which is a bit silly right now. But the goal is kind of, adding a bunch of types or something like this, put some restrictions on what is possible, and we get much smaller initial things with a lot of zeros and a few things. So we first get but for now we get a matrices or tensors where all the cells are a distinct variable, and the goal is to say, yeah, this cell exists or not in the thing. Then we're going to combine them using the relational algebra here, and eventually we're going to get a single formula by doing compile. And that lets us actually express amazingly many things. It's extremely expressive. But we've done like 2/3 of it in 200 lines. So it's not like it's quite impressive how far you can go there. So the next step is to be able to do this recursion thing, which I'm going to do next time. I'll explain next time how we're going to proceed. I'm going to do something simple. I know there are some more clever things, but I don't understand them. So what I'm going to do is a very simple-minded translation to SAT. A smarter approach is to have a somewhat even simpler translation to SAT, but that is not correct. That means that you're going to get all the models out of it, but not all. SAT will sometimes return models that are not legal, that cheat one way or another. And then you have ways to understand that this is a cheating model and that is not correct. The general idea is that because all these are NP problems, and so when you get a solution, I suppose it's not too hard to check whether it's an actual solution or not. It was difficult to exhibit a solution. And when you've done this, then you can just push a new clause through the SAT solver saying, nah, I don't want models of that particular kind. And yeah, so there's sort of more like the SMT floor of things. You just add one thing. You get a suggestion from the SAT solver and say to the SAT solver, no, find me another solution. But you say it in a way that is directed. You don't just rule out this usually. You just find a much bigger formula that says, oh, there's a whole bunch of solution that it rules out, including this one, and just find me the next one, and you go on. And that includes like looking for SCCs in graphs. I've only seen that done on ground instances that without variables, and I don't want to get there. But it's related to the fact that when we're going to take recursion, we're going to take smallest fixed points semantics. So the relation should be the smallest fixed point of a particular expression. And if we do that, we can get values that are non-small fixed points. So we add in formula, say, oh no, that's not that's really making the fixed point minimal. There might be other ways, like in general, doing this, at least when there's negation, but I don't count negation for the moment, it would be like exponential from the get-go. And so like you add an exponential amount of formulas, so it becomes very big very quickly. That's why people do that lazily. I don't know whether it would be the case here. I really don't know. So now, right now, I'm mostly like rambling some researchy things, and that is not being helpful. So what we're going to do is we're going to say goodbye very soon. I'm going to first push. Yeah, okay. I can't press keys on my keyboard. It's funny. Okay, that's on GitHub now. Well, now. Yeah. So program. So next week I'm going to be playing a link to the path randomizer I've been talking about, though I'm not The one I'm doing is probably, it's not actually randomized, it's set up by hand. So I'm going to hopefully finish the holiday festive from December. Yes, that's sort of my goal for next time. And 2 weeks from now, if everything goes fine, I'll continue this with some recursion shenanigans. There might be a hiatus of a couple of weeks after that. Maybe before that, actually. I don't know yet, depending on how. So I've got some deadlines coming, and I might have to work nights, and I might not be like, even if I'm available on Friday, I might not be in any shape or form to perform. I don't exactly know. Until the beginning of March, there's going to be some possible misses. I don't know, but I'll follow on Twitter if you want to have notices, because it's my only way to reach followers. Right. So that was the program. That was not very precise. I don't exactly know how we're going to do this, depending on how much work I have left in front of me. So yeah, next time I work on this, which will be 2 streams away, maybe 2 weeks away, there will be some recursion things, which do imply a bit of pain, but that should be fine. Yes. Right. Okay. I just completely lost my train of thought, but the point is I have said everything I need to say, so I'm going to cut stream in a second. So thank you everyone who joined, participated or not. I hope you had fun. It has been a very silly evening, to be honest, which I think is good. Silly is good. At any rate, I hope it's entertaining, or maybe that you learned something. That would be perfect, especially both. And yes, until next time, don't forget to stay curious. Cheers.